Hello everyone, my name is Okoth Victor and I'm going to take you through understanding machine learning. This is the introduction whereby we are going to be talking about a few things, feature scaling, data cleaning, the EDA. Now when we talk about machine learning and regression, that is our first module. This module was covering a lot of things, so talking about machine learning as a core branch where computers learn patterns from data to improve their performance without being explicitly programmed by every task. Now, when we talk about linear and logistic regression, so we are moving between two fundamental algorithms, that is the linear regression and the logistic regressions. For linear, we want to predict continuous numbers. Then for logistic regression, despite the name, it is used for classification as it predicts probabilities that fall into categories like yes or no or true. Now, when you talk about the k-nearest neighbors, this module, it is our module 2. So for it introduces it is a non-parametric algorithm, meaning that it doesn't assume a specific data structure. Instead, it classifies new data points by looking at the nearest existing points. Yeah, that's what it does for the k points. I give an example. When you use the Euclidean distance, for it is used to catches the closeness of the distances. Then, when you talk about the KNN implementation and the dimensionality, so here we want to see how do we implement this. First of all, we need to understand that the Euclidean distance, it is how we capture the distance between two neighbors. Then, after that, we assign a class based on the majority vote, however, whatever class most neighbors belong to. However, we should know that the KNN has important limitation. That is, it is sensitive to scaling. Then it is also, we have to talk about the curse of dimensionality. As you add in more features, the data points are spread out in high dimensions. Now the decision trees, I also learned that the decision trees, it's part of supervised learning module, splitting data between series of questions or conditions. Each question creates a branch leading to decisions, very easy to interpret and visualize. Then when we talk about how decision trees split data, so how they split data, the trees test different conditions, then they pick the best one at each step. Now, a real example, you can look at the diagram there. Let me say we have choosing between Facebook and Instagram. Now, we have entropy and information gain. For entropy, like how trees they choose the best split, entropy we measure the impurity. Here we shall talk about something like the Gini impurity, the complicity pure, then the mixed, then information gain we measure the split quality. That's all about now, whereby our gain is the entropy before the split minus the entropy after the split. So higher gain is the better split minus the pure groups. Now, when you talk about pruning, here we are preventing overfitting. It removes unnecessary branches from the tree, cuts off parts that do not add real value. Why should we prune? Trees can go deep and memorize training data. Then we can see ensemble learning now. That is also another module. For ensemble learning, we shall combine multiple machine learning modules to work together as one. So this one will improve the accuracy. Yeah, it will improve the accuracy of the modules, giving us better predictions. Yeah. Now, two examples we shall look at: random forest boosting, bagging. Now, when you talk about random forest and bootstrap sampling, here, let's talk about random forest. We shall build multiple decision trees using the bootstrap samples. Then the bootstrap samples, we just collect random samples from the data, allowing the same data picked once more. Then there are also advantages and disadvantages of it. Then we have the support vector machines, the SVM, the optimal hyperplanes that are also there. Then we had the hard margin versus the soft margin. Yeah, here we shall say that soft margins allow some mistakes, real world data, rarely perfect. Then the PCA, the principal component analysis, it is dimensional reduction technique. Then how PCA works. For PCA, we look at the applications, the drawbacks of the of PCA, then the application and the drawbacks of PCA. Like one of it is the interpretability. Yeah? It's hard because the PCA is Bain's original features with no clear real-world meaning. Then feature engineering and data cleaning. Before you can build any model, you have to clean the data. This means handling the missing values, either filling them or removing the repeated data. Yeah. Then parametric and non-parametric models. Parametric models. Then for non-parametric models, you make no strong assumptions about the data shape. So it is the vice versa of the parametric model. Now the key trade-off here, the parametric models, they are simpler, faster, and need less data, but may underfit if the assumption is wrong. Then the EDA, here we shall be looking at the IRIS data set. Explanatory data is the process of investigating a data set before building any models. Yeah. Then we can also see detecting outliers, checking relations, the goal of EDA, identifying patterns within the data. Then in the conclusion, what I learned is, I learned how supervised algorithms actually work under the hood. Then linear regressions draws the lines, K looks at the neighbors, decision trees ask the question, the SVM finds boundaries. Each algorithm has its own logic and its own use case. I also learned why preprocessing is so important. Models are only as good as the data you feed them. Missing values, unscaled features, and messy categories will break even the best algorithm. Model evaluation, when you see, told me that the accuracy is not only measure, but you have to think about overfitting, underfitting, and whether your model will work on new data it has never seen. Now, when you look at dimensionality reduction, showed me how to simplify complex data sets. PCA lets you to cut through the noise, then focus on what matters most, even if you lose some interpretability along the way. Thank you for your time. Yeah.